Lake Superior State University is a small university located in Michigan's Upper Peninsula with a variety of programs to offer. Seniors in engineering are required to complete a capstone project, most of which are design projects, but research opportunities are also available. Team Superior Oscillation Research set out to study hydroacoustic applications to detect oil under ice. Through literature reviews, we hypothesized that small physical changes, such as oil skimmed under ice, would cause a noticeable change in acoustic reverberation times. This hypothesis led to the overall goal of the project, to prove the feasibility that tracking acoustic reverberation times is an applicable method to detect crude oil that has been spilled under an ice layer. To better represent this method, consider a frozen lake. Oil is spilled underneath the ice. We place a hydrophone anywhere beneath the ice. We set off an impulse of source, and from the acoustic waves reflecting off all surfaces, we can collect the reverberation time. To create a scaled model of the previous scenario, we use a 6 by 2 by 2 foot steel tank. Neoprene was added to the walls to reduce horizontal reflections as much as possible. Insulation was added to the outsides of the tank to prevent freezing along the walls. The top surface was frozen by taking advantage of Sault Ste. Marie's cold weather. To collect reverberation times, a hydrophone was placed in the tank and a glass rod was buckled as the acoustic source. To prove our hypothesis, crude oil was added to the test tank under the frozen ice layer. The raw time signals of the many tests were then processed in MATLAB to extrapolate the reverberation times. These times for different scenarios were compared across third octave frequency bands. In these time signals, we can clearly see the difference between open water and ice. Taking the case for ice versus oil, a small but consistent difference can be seen across all measured frequency bands. The oil reverberation times are longer due to the oil layer being more reflective than the ice above it. In conclusion, Team Superior Oscillation Research applied research methods and experiments to show the potential application of reverberation times to detect oil under ice. Future work based on this project includes larger scale testing and investigating the use of autonomous underwater vehicles for deployment of this method. We'd like to give a special thanks to Enbridge for monetary and technical support. We would also like to give thanks to the Coast Guard Sector Sault Ste. Marie and Cetacean Research Technologies.